P.2, it's usually statistics. And they're telling us that Miss Murphy decided to research the effectiveness of her online classes. And then she divided the 12 pupils fairly into 12A and 12B. So 12A attended face-to-face classes, and then 12B attended the online classes. Then both classes were taught by the same person over the same period of time. And then they are telling us that the table below shows the time spent teaching in hours, and then the average results of the learners' weekly tests as percentages. Okay, so this is a bivariant type of data. So we look at the time together with the results, and then the time together with the results. Okay, so time is the independent variable, whereas the results will be the dependent. Then they ask us to determine the equation of the least square regression line of 12A. So we just need to capture this within our calculators. Remember, the steps are quite clear and simple. So we said we always have to start with the mode. And then from the mode, you choose the start. Then after getting the start, we need to look for the A plus BX times it's a small a and a small b x. And then we shall get a table, which table will have the X on one side and then the Y on the other side. So what we said was that the first row will always indicate the X values or the independent variables. So we enter this, we capture that. So 2 equals signs 8 equals signs 4 equals signs 6 equals signs 12 equals sign 10 and 11. Then we also enter the Y values, 42, okay, then we have a 62, and then a 48, then a 52, a 64, 63, and then a 67. So capture that. When all those values are captured, then we can use the on button or the clear all button so that everything disappears. Then we need to press shift and then 1. So shift and 1. Then we're gonna go to 5 that talks about the regression. And then that 5, we can look for the values of A and then the values of B. I think it's option number 1 and then option number 2. So if that is done, our A that we're gonna end up with is 38,26. That's what I'm getting, 38,26 from my calculator. And then the B that I'm having is a 2,456. Let me just round it off to decimals. So it's a 2,46. So remember, our regression must always be in the form of A plus BX. Okay, so when I write that out, it's going to be 38,26 plus 2,46 times X. So that's all they want there. Then 1.2, they want us to write down the correlation coefficient of 12A results with respect to the time. So what we need to know is that these values, since we entered the values of 12A, we can just go back, you press your shift, and the 1. Then we go for the 5, which is regression. And then we go for option number 3 on my calculator that is representing the regression symbol. On your calculators, look for that option, the small r. So my regression is 0.966, which is like 97. Okay, so that is what I'm having. Then 1.3, they want us to comment on the correlation between the time spent. So whenever we are commenting, we look at the value. Okay, the value itself is going to tell us the strength, and then the sign of the value must give us the direction. Okay, so in this case, since it's 0.97, that is a very strong, okay, but it is positive. So a very strong positive relationship. Okay, so that is what we have to do. Okay, so that is 1.3. Then when we look at 1.4, they're telling us that the equation of the least squares of regression of B is given as this. Okay, we need to calculate the difference in the result that is achieved by each class. Had this lady spent an average time to complete a particular lesson. So the key statement here, because we need the value for the time, but they are telling us the average time. So we know that average is the same as the mean, and sometimes we denote it as x bar. So if we go back to our table, we go back to the table that we were given. We have 2, 8, 4, 6, 12, and so on. Let's quickly get the mean for those values. So it's a 2 plus 8 plus 4 plus 6 plus 12 plus 10 and then plus 11. Okay, and then I'm going to divide this by 7. So I got a 53/7. So our mean time that we're talking about is basically 7.57. Now they want us to use the 7.57, substitute it into this regression equation as well as this one, and let's get the difference between the two. So for the first case, for 12a, if I use that line, I'll have my y as 38.26 plus 2.46 times the 7.57. Okay, let me just get my answer. That is plus 2.46 times. That's giving me 56.88. Okay, then let me do the same for 12b. I'm having 15.74 plus 4.54 times the 7.57. Okay, so 15.74, 4.54 times 7.57. I'm getting 50.12 from the round off. Then we need to just subtract these two values since they asked for the difference. So guys, in maths, when they ask for difference, don't write explanations and tell us this is bigger than that, or it's just the subtraction. So 56, we're gonna have 6, having 76. Yeah, something of the sort. Then 1.5, they want us to identify any outlier or an outlier in 12p. So an outlier, we say it is an extreme value. It's either too small or too big compared to the rest of the data. So in this case, the outlier will be a 9 for 12p because it is basically the lowest mark. So how do we indicate that? You have to write us the time that it took place, and then the 9. In other words, the time that was taken to teach this person, and then the results that they got. Then indicate a valid reason for this outlier. Remember, the outlier is falling under the online classes, if I'm not mistaken, because 12B attended the online classes. So we can talk of any valid reason that could come up as a result of online classes. Okay, what problems do people face? Maybe this person couldn't even attend because of load shedding, because of poor connectivity, or this person had their own reasons. But what are those reasons? Okay, so we can just attach it to maybe lack of attendance. Just that. It's lack of attendance because of ABC reasons. All right, so that is 1.6. That is the whole of question 1. Let's look at question 2. Formula 1, the race car drivers have to endure high G forces at extremely high temperatures, and then they tend to lose almost 4 kilograms of weight after every race. Oh, that's too much. 2.1. 2.1. The table below shows the total weight that is lost by 40 different race car drivers after the duration. So we have this grouped data of ours. Okay, we have the classes of the weight loss and then the number of drivers that lost weight. Then they want us to determine the modal class. So a modal class is basically that class with highest frequency. Now remember, the number of drivers will represent the frequencies. So these intervals are representing our classes. So the highest frequency that we are seeing is the 15. So this interval becomes the modal class. So we're going to say 2.5 is less or equal to the weight and less than 3,000. Then they want us to calculate the estimated mean weight loss of the drivers. Okay. So remember, it's a process that was done way back in grade 10, but I'll just try to push it there first. Okay, so we had the X, which X was the midpoint of the class intervals. And then this was the F of X, the product of the frequency, and then that. So we already have the total number. So this is summation of F, the frequency. We know that the estimated mean, which is the mean of this grouped data, will always be given as the summation of Fx over the summation of F. So in other words, we need to get the product of the frequency and the midpoint first, which is a bit different from the one variant kind of data. So how do we get the midpoints? Midpoints are obtained by just adding the upper class as low as and the lower class. So it's 0 plus 500, and then we divide by 2. So this is going to give us a 250. Same story, 500 plus 1,000, then you divide by 2. You're going to get something like a 750. So when you look at the trend that is happening, it's like we are just adding a 250, 250, 250, 250 everywhere. So this is going to be 1,250. And then this is going to be 1,750. And then it's going to be 2,250. And then 2,750. And then 3,250, something like that. And then if we multiply the 250 by the 1, we shall get a 250. 750 by 2, we shall get a 1.5. And then 1,250 times 3, we shall get that 750. And then 1,750 times 8, we're getting 14,000. And then 2,250. 2,250 times 6, that is 13,500. And then 15 multiplied by 2750, that is 4,1,250. Okay, and then 5 times 30 to 50. That's giving me 16250. And then what I need to do is just add up. I need to get the total of all these items. Okay, so let me do that. 1.5, I have 3750 plus 14K, 15500 plus 41250 plus 16250. So my total here is 90500. Okay, so my estimated mean, let me just write this side. This is Christian number. Okay, so estimated mean, it's saying summation of f for x over summation of f. So you have 90500 divided by 40. Okay. So when I divide this by 40, I'm getting 2262.5. So this is basically the grams that were lost on average. All right. Then 2.2. They're telling us that the recording of the weight lost within the second race was made 1 month later. And the amount of weight lost in race 2 was k grams more than in race 1. Okay. It is given that the maximum value of the ogive representing race 2 was 40 and 3504. And then the graph was grounded at 40. Okay. Then they want us to sketch the ogive or the cumulative frequency curve representing race 2 within the answer book. So this table is for which race? They don't tell us. Just looking at the second table. Okay, so what we're going to do with the cumulative frequency, we know that we normally use the cumulative values. Okay, I've used almost my table. Okay, I'll use this other one here. Try to decrease it and decrease it a little bit. Okay, so if this is my table, let me try to indicate the value of the cumulative. If that is gonna make sense. Let's see. Okay, so with the cumulative, we know that the first cumulative will always be the first frequency. Remember, we say this is frequency. So this is for cumulative frequency. And then 1 plus 2, we must get a 3. And then 3 plus 3, we must get a 6. And then 6 plus 8 is a 14. 14 plus 6 is 20. 20 and that, we get a 35. 35 and 5, we get a 40. So our last cumulative must be equal to the total frequency. Then, if we go back to what they told us, this condition of theirs, they told us, remember, these values are for race 1, but we want to play around with this to create the race 2 values. Telling us that the recording of the race was made 1 month later, and then the amount of weight lost in race 2 was k grams more than in race 1. Okay, given that the maximum value of race 2 was 3504 as well as a 40. And then the graph was grounded at 4 and 0. What does this mean? It simply means that the lowest interval is going to be F4. And then this one will be F504. So that when you subtract, you still have the same thing. Then the process continues. Okay, so this will be a 504, and then this will be 1004. 1004, and then 1504, 2004, 2504, 3004, 3504. You can see how it's coming up. And then these numbers will be this side. So 1504, 2004, 3004. This is a 2, sorry. It's a 2504 and a 3004. Okay, so we have that. We have the cumulatives. We just need to plot our graph. Okay. So which means that's going to be, they say they are grounding it at that. Remember, when we are plotting our graph, we normally use the upper classes. Okay, so these classes are what we use against the cumulative values. Okay, so the first one, which is going to be 5004, goes with 1. 5004 goes with 1. 4, 6, 10. So 1 is somewhere there. And then 1004 is going to go with, we said it's a 3. Let me just reduce this that I can see nicely. It's a 3, 6, 14. Okay. So that is a 1. We need a 3. 3 is somewhere there. 6 is somewhere there. And then 14 is somewhere there. Okay, then from the 14, we have 20, 35, 40. So this is a 20. This is a 35. And then we have a 40. Somewhere there. All right. And then all you do is just connect this using your freehand. Using your freehand. And then you'll have the ogive as they want it, or the cumulative frequency. Something like that. Okay. Then they're asking us that how will the race of race 2, or how will the range of race 2 compare with the range of race 1? Now, the fact that we see that the intervals are just varying in the same format, just a -4 and then +4, something like that, or +4 on either sides, there's not going to be any difference, because remember, with the 0, we added a 4 to give us this. And then even with 500, we added a 4. So if you ask for the range, which is the maximum minus the minimum, there's no difference. Okay, you can say it just remains the same. It remains the same. And then determine the average weight that is lost in race 2. Average weight that is lost in race 2. So since we got our average, remember mean is the same as the average. We got it as what? Someone remind us. We got it as 2262,5. 2262,5. But then remember, we are adding a 4 for the lower class, and then we are also adding a 4 to the upper class, which means overall 4 plus 4 is 8, divided by 2, it's 4. So overall, we are adding 4 grams. So you're going to say +4. And then that's going to give us 2266,5 grams. That will be the mean or the average. All right, question number 3, which is the analytical geometry. So in the diagram below, we have A, which is negative 3K, and then B, which is 4,8, C is 5,0, D is negative 4, are vertices of parallelogram. So when they talk of a parallelogram, please let's remember the properties of parallelogram. Okay, we know the opposite sides are parallel, opposite sides are equal, but what is very important is that the diagonals bisect each other. In other words, the midpoint of this diagonal is the same midpoint of that other diagonal. Okay, so diagonals do bisect at P, and then the angles of inclination AB are alpha and beta, respectively. AB cuts the x-axis at P, and then F is a point within the 4th quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. There is F. Okay. Then they want us to get the gradient of BC. So we know that gradient is normally obtained by the change in y over the change in x. y2 minus y1 over x2 minus x1. So when you look at the BC, we have 4,8 and then we have 5,0. So that's going to be, let's say, 8 minus 0 over 4 minus 5. So that is 8 over negative 1, and then our gradient becomes negative 8. So that is the gradient that they need here for BC. Then if the distance between A and B is root 65, can we determine the value of K between A and B? This is root 65. So when they talk about the distance between points, then we're going to use the distance formula. Okay. And we know that the distance formula is, I'll say AB is the square root, or AB squared is all of that. X1 minus X2 squared, and then Y1 minus Y2 squared, or X minus X1, whichever format you use it, guys. So where there is AB, I'm going to use root 65 is equal to the square root of, I'm going to say, negative 3 minus 4 squared plus a K minus 8, but squared. And then I'm going to get rid of the square roots. You square both sides, and then the roots fall away. Okay, so I have a 65 is equal to minus 3 minus 4. It's going to give me negative 7. I square that. I have a 49. When I open this up, I can use my FOIL, K minus 8, and then K minus 8. So that's a K squared minus 16K plus 64. I'm going to regroup this and create what we call a standard quadratic. So I have K squared minus 16K. 49 and 64 is 113. When I subtract 65, I'm getting a 48. I can factorize that out, or I can use my quadratic formula. So which numbers? 48. I can use 12 and 4. I can say K minus 12, then K minus 4 is equal to 0. So either K is a 12 or K is a 4. So we already have the K. Whoa. What's happening? What is happening? Did we mess up with the signs? Did we? Something is not right. No, it's fine. It's okay. We didn't mess up. Remember, K represents the Y values, and both numbers yeah, that's what it's giving us. Either K is a 12 or K is a 4. Oh, that's correct, guys. No need to stress. But when we look at where k is. This k is below the 8. So k cannot be a 12. This simply means at y12, the distance between A and that point is still going to give us root 65. So in this case, since we are saying that k is below this 8, then we're going to take k to be a 4. Okay, so I'm saying k is a 4. That is according to the interpretation of the drawing. Then 3.3. Can we prove using analytical geometry methods that BP, where is BP now? BP, where are you? Okay, that BP is perpendicular to AC. We prove that BP is perpendicular to AC. So for us to prove that, do we need the coordinates of P? We don't need that. I don't know. We can even use the coordinates of D since it's still the same straight line. I suppose we can use that. But what we know about perpendicular lines is that the gradients, which means the gradient of BP times the gradient of AC, it must give us a -1. So this is the condition that we should aim at. Okay. So what I'm going to do, just gonna move this side and say that the gradient of AB, is it AB or BP? Say the gradient of BD, let me use BD. Say y2 changing y over changing x. And then our BD is 8 and -4, 4 and -2. So I'm going to say 8 minus -4 over 4 minus -2. When I simplify that, I have a 12 over 6, which gives me a 2. And then the gradient of my AC, so changing y over changing x, same story. So with my AC, I have a -3 and a 4. And then I have 5 and a 0. So that is going to be, so gonna say -4 minus 0 over -3 minus 5. So this is -4 over -8. Did I do something wrong? Say -4 minus 0, -3 minus 5. That is fine. Okay. This is giving me a half. With the previous one, did we do anything wrong? It was 8 minus -4, which is that. Something's not right. Something I did wrong here. Why am I using a -4 for the y? It's a positive. And see that. So that's a positive, and then we end up with a negative. Yeah. Then if we get 2 times -1/2, that gives us -1. Then we can draw the conclusion that therefore AP, because that was the, they say, no, it's BP. So BP is perpendicular to AC. All right. Then calculate the coordinates of F. If it's given that ACFD, AC, just use a different color. Okay, ACFD, okay, is a pyrogram. Okay, so if this is a pyrogram and we need to find any missing coordinates, we have to use the midpoint. Okay, so we're seeing that this DC is a diagonal. So we need to find the coordinates of the midpoint here. So for us to get those coordinates, we shall say -2. Okay, let me just put it aside. So we're saying the midpoint of DC, will be x plus x1 over 2, and then y plus y1 over 2, or y1 and y2 over 2. Okay, so we see -2 and 5, -4 and 0. -2 and 5 over 2, and then -4 and 0, plus 0 over 2. Okay, so when we simplify this, we have a 3 over 2, and then we have a -1. That is our midpoint. Then, what we said was that if we draw this diagonal also, okay, diagonal AF, this is also going to be the midpoint, which means if I call the coordinates of F to be X and Y, if I get the -3 plus the X divided by 2, I must get the 3 over 2. And then if I get the 4 plus this Y divided by 2, I must get -1. So let's do that. We're saying -3 plus the X of F over 2 must give us this X coordinate of the turning point. Multiply through by 2. So by 2 by 2, this cancels that, this cancels that. Move the X move the 3 that side, so X is a 6. And then we're saying Y plus a 4 divided by 2 must give us -1. Multiply through by 2 also. This cancels. So Y is -2 minus 4, which gives us -6. So which means F is going to be 6 and -6. So those would be the coordinates of F according to the question. So remember, if you're looking for missing coordinates, in most cases, we use the midpoint, depending on the values that we have. Did we do this correctly? This was a 4. Whoa, 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 whoa. Is that true? Is that true? Is that true? Is that true? Someone is complaining, saying there's something we did wrong. So Y plus 4 over 2 must give us, so, oh, the midpoint. Guys, let's go check our midpoint values. Someone is not happy. Happy. Okay, so with the midpoint, remember we said midpoint. What was our midpoint? We said -4 plus 0 divided by 2. That's all. This was our midpoint, which gave us a -2, not a 1. Yeah, it's making sense. So it's a -2, guys. Sorry. And then if this is a -2, then that's going to be -4. -4 minus that is going to give us -8. So that is -8. Thank you very much. Then 3.4 is done. Then they want us to get the size of EDO, correct to 1 decimal place. EDO. Where is EDO? Let's change this. Something like EDO. This is E. This is D. And this is O. EDO. So they want us to get this angle here. So for us to get this angle, we need to first of all get the angle alpha. Okay. And then we also need to get the angle beta. So we know that this angle beta is going to be the same as this angle. It's the same thing. which means for us to get this angle of ours, we shall have to combine this angle and the beta to give us the alpha. So we got the gradient of BC, which was -8. But this gradient is the same as the gradient of AD. So let's use the inclination formula. So we know that M is equal to the tan of alpha. Our M is -8. So alpha is going to be the arctan of -8. Okay, if I substitute that, I'm getting -82,875. I will just add 180 to get the positive angle, which is a 97,13 degrees. Let's look at the beta. If this is 8 and it's passing through the origin, so the gradient is going to be 8/4, which is a 2. Someone can use 8 and -4, which will give you a 12, 4 and -2, which will give you a 6, to still give us a 2. So I'm going to say that my beta is going to be the shift tan of a 2. So shift tan of a 2 is giving me 63,43. So this angle is a 63,43, and we say it's the same as this because they are vertically opposite. This we got as a 97,13. So when we get this 63,43 plus this angle must give us that because of exterior angles of a triangle. So we can just quickly say that for us to get the ADO, okay, so ADO will be just the difference between the two, 97,13 minus 63,43. When we subtract that, 97,13 minus 63,43, I'm getting 33,7 degrees. Just that. Or is that 3.4? I'm just misaligning the questions. Yo, guys, I'm sorry. That is 3.5. That is meant to be 3.5. Okay, this is meant to be. Okay. Then 3.6, they want the area of ADC. ADIC. For marks. So what do we know? What do we know? What do we know? Remember from the area rule, we must have two sides known as well as an angle. And let me just clean up this drawing. Just clean the drawing up so that we have a clear view. Okay. So then they want us to get area of ADC. AD and C. So this triangle here. So since we got this as a 33,7, and they told us that this is a pyrogram according to the information that was given. So if it's a parallelogram, which means even this bottom part must be a 33.7 because the diagonal bisects these angles. If that is true, we can find this distance AD, and we can also get the distance DC. What did they tell us? They told us that the distance was root 65. Okay, if that is a root 65, so which means we have this as a root 65. We only need the distance of AD. Okay, so we shall say AD will be the square root of -3 minus -2 squared. K was a 4 minus -4 squared. Now I punch that into the calculator of -3 squared. What is happening? Plus, I'm getting also root 65. Does that make sense though? 3 minus, which is a 1, that is 8. Getting root 65. I don't know if that's going to make sense. If that is going to make sense. Or is what I don't want to use is that other angle. Yeah, let's see, guys. It's a -3 minus -2, 4 minus -4. Let me just confirm it, guys, just to be sure. Minus -2 squared plus 4 minus -1. It's a 4. We square that, which is root 65. No, it's okay. Let's go with it and say the area now is going to be a half times this root 65 times that root 65, and then the sine of these angles combined. So 33.7 times 2 is giving me 67.4. So when I punch that into the calculator, 67.4. I'm getting 30,0000. So which means it's just 30 units squared. It's okay, guys. That will be the area that is needed. Then that is question 3. Then question 4, dealing with the circles. Telling us the diagram below, the equation of the circle N is given as that. And then QT is a tangent to the circle T. T and P is the diameter of the circle. Have point P, which is 5, and 4 lies on the circle. All right. Then the question is that, can we write the equation of the circle in this other format? So in that format, all they want us to do is complete the squares. Okay, so how do we complete the squares? That we need to know. So we're going to say x squared plus y squared minus 4x minus 2y minus 13 is equal to 0. So step number 1, some people prefer to move the 13 that side. But it's no big deal. You can even work with it when it's this side. So if I take it that side, say minus 4x, why don't I just try to rearrange as well? So it's x squared minus 4x plus y squared minus 2y must give me a 13. Then when we are completing the squares, we just look at the b value for x and y. Okay, so the b value there is a 4. So we're going to half it, and then we square it. So that's going to be x squared minus 4x, a half of this. That's going to be 2, but squared. I'll do the same thing. This is y squared minus 2y, a half of that is just 1. When I square that, is equal to 13. Now, since I'm introducing these squares, I must also do the same on the right-hand side. So that's going to be a 2 squared plus a 1 squared. Then that represents our quadratics, and then you can factorize that. So that's going to be x minus 2. So x with this sign, and then that number that you squared. And then plus, we're saying y with this sign, and then the number that we squared must give us, this is 13 plus 4, that's 17 plus 1 is giving us 18. So that is how we would have completed the squares. Alternatively, what we are always told, just as a quick approach, just x and then y, just get a half of this with a sign. So it's a negative with a 2. Then a half of this with a sign, -1, you square that. And then you just add those squares that side. You just get that fast, without going through this long process of breaking that down. Okay, then write down the coordinates of n, which is the center. So n is going to be 2 and then 1. We switch the signs, +2 and +1. Then they want the length nt. Nt is the radius, but remember this 18 of ours is the r squared. So for us to get r alone, you must get the square root of it. Okay, so nt is square root of 18, which is 3 root 2. If I was to simplify that. Then 4.3, determine the equation of the tangent QT. Tangent QT. So we know that since we have the coordinates here as 2, 1, we want the equation of the tangent. We need the coordinates of t first. And then after getting the coordinates of this, we also need the gradient of Pt. Then we shall be in position to get the equation of the tangent. Okay, so I'm going to start with determining the gradient. So I'll say m of Pt is going to be 4 minus 1 over 5 minus 2. So that is a 3 over 3, which is a 1. Okay. Then the equation, from write the equation, remember it's y is equal, okay, y minus 1 is equal to 1 into x minus 2. Or you can use the mx plus c1. When I open that up, I'm having y is equal to x and that is x. I'm going to have a -2 and then a +1. So it's x minus 1. This is the equation of the diameter. But then this equation or this line is meeting the circle at 2 points. So I'm going to work with this and then the equation of this circle and solve them simultaneously. Let's go that side, it's 4.3. Okay, so we said x minus 2 squared, y minus 1 squared is equal to 18. And then we have y is equal to x minus 1. So where there is y, I'm representing that or substituting. So I'll open that, not yet as Let me just substitute. So I'm going to have x minus 1 minus 1, but squared is equal to 18. Open this up. I'll have x. Why should I waste a lot of time? Because I know that this is going to be also x minus 2 squared. So I have 2x minus 2 squared is equal to 18. Divide both sides by 2, x minus 2 squared is equal to 9. And then I find the square roots. So x minus 2 will be plus minus 3. When I move the 2 that side, x is a 5, which 5 is this one, the p. Oh, if I move the 2 with a negative, x is going to be a negative 1. Because this is going to be a 3 plus 2. It's going to be a negative 3 plus 2, which is negative 1. So we have the x coordinates. Okay. I have the x coordinate of this t, calling it a negative 1. Then let's get this negative 1 and substitute it into this equation of the line, which means y is negative 1 minus 1, which means the y is negative 2. So t is negative 1 and negative 2. Okay. Since we got the gradient to be 1, and we know that a tangent and the diameter, or tangent and radius, must be perpendicular from our Euclidean geometry. If that is true, which means the equation, the gradient of the tangent, okay, I'll just say gradient of the tangent must be negative 1. Since we say that the two gradients, the products of the two gradients must give us negative 1. So it's like a negative 1 times another gradient of the tangent must give us negative 1. This was a positive, sorry. And then when you divide both sides, you get a negative 1. Okay, so negative 1 as a gradient and the coordinates as that. So I'll say y minus minus 2 is equal to my gradient, which is negative 1, into x minus minus 1. I'm using this kind of format to determine the equation of the line. Like we said, mx plus c can also work perfectly well. So y plus 2 is equal to negative x minus 1. When I move the 2 that side, y is going to be negative x minus 3. That is what I'm getting for the equation of the tangent. If you have a quicker way, you can always share it with us. Thank you. Then 4.4, they are telling us that a circle with S, that is AB, touches the circle with N externally at point T. Just to refresh this, that I clear. Okay, so we have another circle that is touching at T. I don't know whether it's big or small, but it's fine. Let me use that. Okay, so if this is extended, that's going to be S with A and B. What they are telling us is that this tangent is tangent to both. If NS, the distance from here up to there, is 3nt, can we determine the coordinates of S? So guys, we got the coordinates of T, which were negative 1 and negative 2. Okay, we got the equation to be y is equal to negative x minus 1. And we also got the radius to be a 3√2. Okay. Let's go back and fix this, because I see that 3nt is in a wrong place, telling us that ns. Okay, guys, so with 4.4, what we're going to do, we said ns is 3nt. Okay, so if we square the ns, we're going to end up with 9nt squared. We're squaring it so that we simplify that whole thing. Okay. But since we already have, what is that thing? Remember, if this circle were to be drawn, that is n. It told us that this distance is 3nt. Okay, when you simplify the 3 times the 3 root 2, you get the 9 root 2. When you square that, that's how you're getting the 162. Okay. So this 9nt squared, okay. If we apply the distance formula, it's going to be a minus 2 squared plus b minus 1 squared must give us the 162. So we're looking at the distance from here up here. Remember our n was 21. So a minus 2 squared, b minus 1 squared. Okay, let's call that equation number 1. But we know that nt and qt, those are perpendicular lines. Okay. If they're perpendicular, the product or the gradients will be -1. So if this is perpendicular, even this line will be perpendicular. Remember, our t was a negative. Was it -1 and 2? No, it was a -2, a -1. So let's try to get the gradient of this and equate it to the gradient of that line that we got as a +1. So we're going to say b minus -2 over a minus -1 must give us 1. So b plus 2 over a plus 1 must give us a 1. Let's try to make b the subject, which is a minus 1. Or alternatively, even from that equation of the x minus 1, if you replace b and a, you just straight away get to that. Then we need to substitute this b with that. So it's a minus 2 squared plus b, which is a minus 1 squared, is equal to 162. Okay. Let's open this up. We have 2 into a minus 2 squared is equal to 162. Divide both sides. That's going to give us 81. Square root of 81 is plus minus 9. That's going to give us a minus 2. And then we can move the 8 to that side. So either a is 11 or a is going to be a -7. Okay. Then we substitute these values into that. So which means b is going to be the -7 minus 1, which is -8. So which means s is -7 and -8. All right. Question 5. They're telling us that in the diagram below, point P is this and it's having a reflex angle, which is 2 theta, as shown in the diagram. And we can see that it is in quadrant number 3. So one thing that we need to do, one thing that you need to remember is completing this triangle. So this -3 is for the x, and this -3√3 is for the y. Now we need to find the hypotenuse. That has to be our first priority. So from Pythagoras, we know it's x squared plus y squared. So I'm going to say square root of -3 squared plus -3√3 squared. Now punch that. We have -3 squared plus -3√3. That's squared. So that's giving me a 6. So remember, this answer of yours should never be negative in any way. You must always have positive values. Then from there, we can now answer the question of cos, because we know that cos is adjacent over the hypotenuse. So our adjacent is -3, and then the hypotenuse is a 6. So the answer becomes -1/2. All right, then they want the sine of theta. Sine of theta. So it will be your choice on how you come about with the sine theta. But remember, the question gave us a double angle. So we can use the double angle of cos, where we know that the cos of 2 theta from our formula page, let's just rush there. From the formula page, we can use this one. 1 minus 2 sine squared. So that's going to be 1 minus 2 sine squared theta. And let's try to make sine theta the subject. So it's going to be 2 sine squared theta is equal to 1 minus cos 2 theta. Then we can divide both sides and take square roots. And so sine theta is going to be the square root of 1 minus cos 2 theta over 2. When we substitute our cos 2 theta, which is -1/2, so it's going to be 1 minus -1/2 over 2 under the square root. You can go bit by bit or just at once, no problem. Okay, we're dividing by 2. I'm getting a √3 over 2. So we need to see all these workings out. Then 5.2. They want us to simplify this. Okay. Let me just do it this side. 5.2. So we have cos squared 180 plus x. Cos squared 180 plus x. And then we also have a cos of -x. Okay. And then we multiplying by the tan x. Multiplied by the tan x. Multiplied by the cos of 90 plus x. So we need to apply our reduction rules. So 180 plus, that is quadrant number 3, where the cos is negative. So it's going to be negative cos x, but we're squaring it. And we say the cos of a negative angle is the same as the cos of a positive. So we ignore that and use it as a positive. we could change this into something like sine x over cos. Okay, and then the cos of 90 plus, this must always give us a negative sine x, since those are complementary angles. So what we see is that this is going to give us a cos squared x. This is going to cancel that and that we have negative sine squared x. So cos squared x minus sine squared x, this is a double angle of cos. So that's the same as cos 2x. That's what I would get. Then consider the equation 5 tan theta minus 6 cos theta. Can we show that this equation can be written in this format? Now with this format, we are only seeing the signs there. We don't have a tan, we don't have a cos. So what I'm going to do, let's see. We have 5 tan theta. We are subtracting 6 cos theta is equal to 0. So this question would have also come in the form of, can you prove that this can also is the same as that? So step number 1, since we don't have a sign by, so we don't have a cos or a tan by our answer, we need to change. That's going to be 5 sine theta cos theta minus 6 cos theta is equal to 0. Then we're going to multiply through by the cos. So cos theta times cos theta times cos theta. So this cancels. You have 5 sine theta minus 6. This is sine. Why am I saying sine so fast? That's cos squared. Theta is equal to 0. Then let's change the cos squared into sine. That's going to be 1 minus sine squared theta. Then just open this up. You'll have your 5 sine theta minus 6. And then this and this will give you plus 6 sine squared theta. Rearrange this. So it's a 6 sine squared theta plus a 5 sine theta minus 6 is equal to 0. I think that's what they had. It's a plus 5 sine minus 6. Correct. Then they want us to determine the general solution. So with general solution, since we've already changed these to just one trig ratio, then we can use the quadratic formula to determine our reference angles. Or we could just vectorize it out. Whichever one would be quicker and easier. Okay. So if we use the quadratic formula, that's going to be our A, that's our B, and then that's our C. So if I try to use that quadratic formula, I substitute that. I have 6. Come on, I have 6. Okay. All right. Okay. So I'm having the first x. Now remember, our x's are representing the sine theta, because that is the x. So you can have sine theta as a negative 3 over 2, or the sine theta as a 2 over 3, after using the quadratic formula. B squared minus 4ac over 2a. This is minus b. When I substitute my 5 plus minus square root of the b, which is a 5 squared minus 4, the a is a 6, that's a negative 6 over 2 times 6. That's what I get. So then First reference angle, shift sine of -3/2. I'm getting -90 plus what. But by virtue of the fact that this is -1,5, it's going to give us an error. So it's not applicable when it comes to sine, because I'll be ending up with imaginary values or imaginary numbers. Okay, which means I'll be left with the 2/3. So the shift sine of 2/3 is giving me 41. Okay, so our reference angle is a 41,8, and this is quadrant 1. So we shall say 41,81 plus k times 360, which is the period, and then k is an element of integers. This is quadrant number 1. And then quadrant number 2, because we know that sine is also positive in that quadrant, it's 180 minus this 41,30. So 180 minus 41,81 plus k times 360. I simplify that, I'm getting 138 plus k times 360. K is an element of integers. So that's what would have been done. So start with the quadratic formula, the solutions. So this is not going to give us any solutions. And then we end up there. Okay, then 5.4. 5.4. 5.4, they want us to prove we have enough space down. Not that much. Can we prove that this is the same as that? Okay, let me just rewrite it again. To rewrite this again, as much as it's going to take a lot of time. But I remember this question was cut out last year. This question was cut out. But it's fine, let's give it a try. So we have a cos 2 alpha plus 77. Okay. And then you have a cos alpha plus 47. Okay, and then this is minus sine alpha plus a 47. And then sine 2 alpha plus 283 is equal to cos alpha plus 30. Okay, so there's nothing much I can do about the first ratio, this one. I just need to play around with this. In which quadrant is 407? That is the first quadrant. And which angle? We know that first quadrant is the same as 360 plus theta. So which angle do I add to 360 to give me 407, which is a 47? So 47 plus 360 must give me this. So if I'm to reduce this, because now it's going to be a cos of 360 plus the 47 plus the alpha now. Okay. I'll keep my 2 alpha plus the 77. When I reduce that, I'm only going to be left with just the cos of this. Then I'm going to keep the alpha and the 47 then. Where do I find 283? 283 is in the third quadrant, which is 180 plus something. So 283 minus 180. I won't use that. That doesn't make sense, man. No, 283 is in the fourth quadrant, not third. Low. So 360 minus 283. It's 77. Okay, so that's the same as the sign of remember in the third quadrant. So in the fourth quadrant, it's a 360 minus theta. So I'm gonna say 360 minus our 77. Is it gonna be minus again, the alpha? Yeah, it must be a minus. So that we keep it as a plus. All right. So let me just simplify that. So I'm gonna have cos 2 alpha plus 77. And then I'll be left with a cos alpha plus 47 minus, I have the sine of alpha plus 47, and then the sine, this is gonna give me negative sine, because the sine is negative within the fourth quadrant. So it's a negative sine. I have alpha plus 77. So this negative and negative will make that a positive. So cos 2 alpha plus 77 times the cos alpha plus 47 plus the sine alpha plus 47, and then the sine alpha plus 77. So this is a compound angle, but it's a compound angle of cos. What happened? There was a 2 alpha, man. It's meant to be a 2 alpha somewhere here. So that this is also 2 alpha and 2 alpha. Okay, so then, because we can see 2 alpha 77, 2 alpha 77, alpha 47, alpha 47. So it's just a compound angle, of course. And if there's a plus, if I call this my A, and I call this my B, it's gonna be the same as cos of A minus B. Okay, so I'm gonna say cos of 2 alpha plus 77 minus, this is going to be alpha plus 47. Because when you open these compound angles, you end up with that. Then I can open this up. I have the cos 2 alpha plus 77 minus alpha minus 47. Then 2 alpha minus alpha, that will give us just an alpha. Then 77 minus 47 will give us a plus 13, which is the same as the right-hand side that they wanted. All right, so that is that. Then 5.5, they want us to solve for alpha and beta. The sine of 3 alpha minus beta is equal to 1 over root 2. If 3 alpha minus beta is between 90 and 270, quadrant 2 or 3. And then at the same time, they're telling us the tan 2 alpha plus beta is equal to this. So let's get rid of these ratios and just focus on the variables alone. So for me to get rid of this, I must find the shift sign of 1 over root 2. Okay. So what is 1 over root 2 shift sign? Okay, the arc sine of 1 over root 2 is going to be 45. But they're telling me that the focus is 90 and 270. That's where the focus is. So which angle is that going to be? We're seeing the sign to be positive here, the ratio to be positive, which means it's going to be in this second quadrant. And in this second quadrant, it's 180 minus. So I'm going to say 1 minus 45. So we can say that 3a minus beta is equal to the 180 minus 45. Remember, first step was to get the reference angle. When you subtract that, 3a minus beta will give us a 135. Then when you look at the tan is also positive. They're telling us with the same ratio. So between these intervals, where do we find tan to be positive? It's in the third quadrant. Third quadrant is 180 plus. So what is the shift tan of 1 over root 3? Shift tan of 1 over, come on, root 3. I'm getting a 30. So here I'll say 180 plus 30, which will give me a 210. So I have 2 alpha plus beta is equal to 210. Then I can subtract the 2. Does that make, why am I saying minus here? Yes, it's a minus, because that's what they gave me. Then equation 1, equation 2. I can just plus this so that this dies out. So I have 5 alpha is equal to 135, and that I'm having 3, 4, 5. Divide both sides by 5. So 3, 4, 5, divide by 5. I'm getting a 69. Guys, getting 69. Okay. Then for me to get the beta, I can just go back to either equation 1 or equation 2. So if I use equation number 2, I'll have 2 times 69 plus beta must give me 210. So it's a 210 minus 2 times 69. That's 138. So 210 minus 138, I'm getting a 72 for beta. All right, so that is 5.5. Then question 6, which is the trig functions. In the diagram, we have f of x, 2 cos x, that is drawn in this interval. Can we draw the graph of g, which is negative tan x within this interval? So guys, it's up to you. Either you use your table or you use the calculator. Okay, whichever one just gives you the results quickest. So that is that. They don't have a g. I'm starting from negative 90. I'm ending at 180. And then the steps are 30. What did I do wrong? Let's do it again. Table, that's the function. I'm starting at negative 90. I'm ending at 180. Steps are 30. All right. So my calculator, are you in the right mode? So I have a lot of values, but they seem to be too small. They're very, 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 very small. Something's wrong with my values. Because it's the same thing. Say negative 2. Oops. Perfect. Okay, so negative 90 is giving me a negative 1. Then negative 60 is an error. So which means that's an asymptote. Whenever we have errors by the turn, it's an asymptote. Then negative 30 is a positive 1. 0 is a 0. Then 30 is negative 1. 60, it's an error. Then 90 is a 1, positive. 120 is a 0. 150 is a negative 1. And then 180 is an error, which means it's an asymptote. Okay, so remember the direction of the turn graphs, or the shape moves towards the asymptote. And then this can move towards, come there, and then towards the asymptote. And then this one will also do the same thing, just in the format, and then move towards the asymptote. Remember, the asymptote is at 180. Okay, so that is the G for max. Then they're asking us to determine the period of G. Now remember, normal period of a turn graph is meant to be 180. But then the moment we have something extra there, it will affect the period. In other words, we can just divide the 180 with this. So if I get 180 divided by 3/2, it should give me 120. Is it 180 divided by 1,5? Come on, calculator. Divide by 1,5. I'm getting 120. So my period is 120. So after 120 degrees, I should have a full graph of 10. All right, then 6.3. They want the values of x in the interval for which f is decreasing. Where is f? This is f. So where is f decreasing? So from this point, because that's the turning point, the maximum, it's slowing down towards 180. So we're going to say 0 is less x is less 180. Okay, so 0 is less x, and then it's less 180. So those are the values for which the graph is decreasing. Then use the graph of G to determine which values of x will G of x be greater or equal to 1. So where do we find the graph of G to be above positive 1? So we can see that from here, because that's a 1. So this area, the G is above 1. Same story here, the G is above 1. So we can talk about the interval of negative 60 and negative 30, or 60 and 90. Those are the intervals that they need. So we're saying negative 60 is less x or equal to x, less or equal to negative 30. And then the other one that we said was, why am I saying equal to with 60? Come on. It's an asymptote. It's not going to cut. So that is not meant to be there. Then this is going to be the same story. We have 60 is less, x is less or equal to 90. Something like that. We'll give you the mass. Then 6.5. They're telling us that h is a function that is obtained by translating G 30 degrees to the right. Okay, they want the equation of h. So we are translating G. G is this turn graph. 30 units to the right, we're moving it in this direction. That's not really relevant to us now. But let's just look at the equation itself. So it's going to be negative turn. Remember, it was 3/2x. Now, if you shift the graph to the right, we shall subtract 30 from there. So that's going to be h of x is going to be negative tan 3 over 2 with the x, I'll say x minus 8. That would be my equation. Okay. Then if you want, you can open this up. That's if you want. But that is still perfect for me. If somebody opened it up, it will be 3 over 2x minus 45. That is if everything is together, but this just enough for the 2 marks. Okay, question 7. The trig application, which is the 2D, 3D trig. It's telling us that in the diagram below, AB is a pole that is anchored by 2 cables at C and D. And B, C, D are just in the same horizontal plane. B, C, D. B, C, D. Horizontal. Okay. And then the height of the rope is H. A is a theta. The angle between CAD is 2 theta. AC is the same as that. Okay, indicated. Then they want us to determine one mega question. They want the distance CD. This distance is what they need between the 2 anchors in terms of H. So what I need to do, I can start by finding this distance, the AC, in terms of H. Because if I have this H, I have the theta, and then I have this 90. I can use the trig rules or the trig ratios. So this is the opposite, this is the hypotenuse. So we can use sine. So you can say the sine of theta is equal to the opposite, okay, which is H, over the hypotenuse, which is AC. Can make that over 1 and cross multiply, which means my AC is going to be H over the sine of theta. I don't need to name it, but it's fine. So this side is H over sine theta. So even this is H over sine theta. Now they want us to get the distance between. So for us to get this distance, we don't know this size, as much as we know that this angle must be the same as this angle. Okay. You can work it out that way. Whereby if this is 1, this is 2 theta, then these angles are going to be 180 minus 2 theta divided by 2, which is basically 90 minus theta. So this is a 90 minus theta. That's also a 90 minus theta. We can use that. And then we use the sine rule. I don't know, I think that's quicker than using the cosine rule, because squaring those things, it will be something else. But let's see. Yeah, I think that's better. So after getting this, let's say that B is the same as D. Angles opposite, equal sides. And then we're saying 180 minus 2 theta over 2 must give us 90 minus theta. Okay, so A, no, it's B is equal to C. Why am I saying P? It's a D. Malumio. Okay, so D is the same as C, which is 90 minus theta. Then I'm going to apply my sine rule. Remember from the sine rule, we said if you have A over sine of A must give you C over sine of C, or B over sine of B. We're looking for the side, so I'll prefer using this kind of format. So I'm going to say CD over the sine of 2 theta. Must give me my I use this, I can use this too, either this or that, doesn't matter. So let me use AB. AB. That is AB, which is h over sine theta divided by the sine of 90 minus theta. Okay, so since I'm looking for CD, I can multiply both sides by sine 2 theta. So CD is going to be h over sine 2 theta times sine 2 theta over the sine of 90 minus theta. Then I can reduce this, which is h over sine theta. We know that the double angle of sine is 2 sine theta cos theta. When we simplify this with the reduction, that's going to give us just the cos theta. So this can cancel that. I'll be left with 2h cos theta over cos theta. And then the cos theta and the cos theta will also cancel, which means CD is twice h. I don't know, guys, but that's how I would have gone about it very fast, because that cosine rule was going to show me flames.